Hey there, welcome back to Anybody Can Prompt's weekly research highlights. We've got some awesome papers for you today. Dive into explainability techniques for LLMs, TradeGPT, LLMs as optimizers, and more. Links are included in the description. First up, a new survey paper focuses on the growing need for explainability in large language models. As these models become more powerful and widespread, understanding how they make predictions is critical for safe and ethical deployment. This paper introduces a taxonomy of techniques to understand these models better and discusses how to leverage explanations for debugging and performance improvement. The paper underscores that as large language models are increasingly utilized, making them explainable is not just a technical challenge but an ethical imperative. Secondly, a paper on budget-friendly training of large language models caught our eye. The authors were able to train a model with 101 billion parameters on just a $100,000 budget. The paper discusses innovative strategies to make training cost-effective without sacrificing performance. The study also introduces a new IQ evaluation metric aimed at assessing a model's intelligence rather than just its knowledge-oriented abilities. Our third highlight delves into the potential and limitations of using large language models in healthcare. From administrative tasks to medical research, these models can offer various applications. However, the paper points out that significant challenges like data quality, patient privacy, and underlying biases need to be resolved for practical adoption in healthcare settings. Next, a paper evaluating the capabilities of large language models in retrieval augmented generation, or RAG, brings forth key insights. The paper introduces a new benchmark for RAG and evaluates current models based on 4 fundamental abilities: noise robustness, negative rejection, information integration, and counterfactual robustness. The study finds that while these models show some strengths, there's still a long way to go in terms of their effectiveness in RAG. Next, a paper that addresses a significant concern in the era of LLMs, user privacy. While using services like ChatGPT, users inevitably expose their private prompts to the service provider. This research proposes a framework, referred to as HAS, which stands for Hide and Seek. The paper introduces a practical method for locally anonymizing and de-anonymizing user prompts, maintaining a balance between privacy and utility. 2 unique schemes for hiding and seeking private entities are discussed, along with adversarial models to evaluate resilience. The team also open sources datasets and models for privacy entity anonymization and de-anonymization, making it a valuable resource for the research community. Next, we turn our focus to a paper that explores the use of LLMs as optimizers. Named Opro, this approach uses LLMs to generate new solutions for optimization problems described in natural language. The paper shows that this model can outperform human-designed prompts and tasks by up to 50% and provides case studies in both linear regression and the traveling salesman problem. Significantly, this work opens up new avenues for quick adaptation to different tasks by changing the natural language prompt description. Next, a study emphasizes the importance of bias awareness in large language models, specifically in instruction tuning. Rather than suppressing inherent biases, the research aims to make them explicit and transparent through a web demo. Users can select multiple biases like political, geographic, gender, or age and ask questions. The model will respond in a manner reflective of these biases, offering a tool to study the influence of bias in natural language processing and encouraging a more comprehensive perspective. The team is committed to ethical considerations and has not made the model publicly available to prevent misuse. Finally, a new paper introduces an innovative multi-agent trading system employing large language models. The paper addresses limitations in memory processing by incorporating layered memories, resembling human cognitive processes. These agents debate and decide on trading actions, each embodying individual trading characteristics like risk preferences. The system promises adaptability to historical trades and real-time market cues, aiming to outperform other automated trading strategies. It opens up opportunities for applications across diverse sectors, such as video games and healthcare. Subscribe to Anybody Can Prompt's YouTube channel today for more exciting developments in the world of generative AI. And remember, anybody can prompt.